I want to know what is the pH of 0.1 molar hydrochloric acid, please. What's the pH? Is it a strong or weak acid? It's a strong acid. Why? Sorry? It completely dissociates. How do you know? Because I haven't given you a pKa in this case. Well, that is sort of the in a way, the easy explanation. So what's the pH of that? 1. So pH equals minus log of the acid concentration in this case. And we always have to do that in molar. So pH of minus equals minus log of 0.1. And that gives 1. Okay, that was easy. pH of 10 millimolar hydrochloric acid. What's that? Still a strong acid. What do you need to do? You have to convert the millimolar into molar. So that is 10 times 10 to the minus 3. And that gives you 1 times 10 to the minus 2. So what's the pH? Loud? It must be 2, exactly. Because we have pH equals minus log of the acid concentration 1 times 10 to the minus 2. We have to have it in molar, don't forget. And that gives you pH equals 2. Excellent. pH of 0.1 millimolar hydrochloric acid. What do you get? We have to convert that again. 0.1 times 10 to the minus 3 molar. That's 1 times 10 to the minus 4. Is that right? Yeah. So the pH would be 4. Equals 4. Wonderful. Can do that? No problem. Easy. pH of 1 nanomolar hydrochloric acid. What's the pH? pH equals? Loud? Can't hear you. It's 9. Are you sure? Are you sure? Loud. Say it loud. pH 9 is a base. And what do we deal with? We deal with an acid, but pH 9 is a base. Do you see the problem? We calculate its pH 9 for an acid, but it is pH 9 indicates it's a base. There's something fishy here. Does that bother you? Obviously it bothers you. What's going on here? Any suggestions? You said you've done that at school? Is that pH 9? Is that right?
Yeah, it's a base.
It's a base. It would make it a base, pH 9. Right? But we are dealing with an acid. Help me out here. WTF? What's going on? You look still, you still look shocked. We basically converted an acid into a base, huh? What's happening? Any such...
Small to do anything.
Sorry?
Is the concentration too small to do anything to, change the pH or something?
Ah, we are getting close to something here. What is the concentration of the protons here? It would be 1 times 10 to the minus 9 mole per liter. Right? That's the protons. What is the concentration of protons in pure water? Loud? Excellent. In pure water, we have 1 times 10 to the minus 7 mole per liter. So, in our pot, we have the protons from the acid, 1 times 10 to the minus 9 mole per liter, plus the protons from the pure water, 1 times 10 to the minus 7 mole per liter. So we have 1.01 times 10 to the minus 7 mole per liter, because if you add 1 times 10 to the minus 7 plus 1 times 10 to the minus 9, you get this number here. Right? True? So when we deal with a very dilute acid, what we have to do is we have to take the concentration of the protons of pure water into account. So, pH equals minus log of 1 times 10 to 1.01 times 10 to the minus 7. What does that give you? Equals 6.99. Acid or base? It's just a little bit below neutral, but it's still on the acidy side. Hallelujah, praise the Lord. We didn't convert an acid into a base all of a sudden. Are you feeling now relieved? Yeah, feeling better, because it is still an acid. But it's so dilute that we actually have to take that into account, that we have protons from the water. Does that make sense? It's actually one of my favorite exam questions, because then I can tell who attended the workshop and who can remember it, or even who understood it. Okay, what is the pH of 0.1 molar sodium hydroxide? You can discuss it. Any ideas?
13. pOH is 1, so pH is 13.
Good, thank you. That was easy. Sorry?
I don't even have to calculate, I have to do it in my head.
That's why I do what I do, you know. Don't use a calculator. Acid or base? The base. So we know already that the pH must be higher than 7. Very good thinking. So you can't go wrong now. Can we directly calculate the pH if it is a base? Not really, because for a base, pH means, you know, acidy stuff. So in this case, we have to do a slight detour. We can't directly calculate the pH, but we can calculate the pOH. pOH equals minus log of the OH minus concentration. OH minus concentration would be, since it is a strong base, would be 0.1. So the pOH equals 1. We know that pH plus pOH equals 14. So pOH plus pH equals 14, and therefore pH is 13. Higher or lower than 7? It's higher than 7. We said originally we have a base, so it must be higher than 7, so probably a good answer. Yeah? Happy with that? pOH of 0.05 molar sulfuric acid. Talk to each other, convince each other, help each other. Bless you. So each of the of the sulfuric acid molecules, how many protons does it give off? It's 2. So we have 2 H plus. That makes our concentration of H plus 2 times 0.05 molar. Yeah? True? So that gives us 0.1 molar of protons. Can we do the POH directly from the acid? No, because it's an acid and we are looking for the POH in this case. So what we can do is we do the pH first. pH equals equals, what does the pH do? What is it? 1. Because log of 0.1 is -1. Minus log is 1. And now we have pH plus POH equals 14. And therefore, POH must be 13. Right? No major problems. Okay. I have an acid. And this acid is supposed to have a pKa for this acid is 3. Strong or weak acid? Sorry? It's a weak acid. Why? Because I've got a pKa here, and the pKa usually indicates that the acid is not terribly strong. What does the pKa again say? It gives us an idea about the dissociation constant. Absolutely right. So in this case, we would have HA dissociates into H plus plus A minus. And of course, we can write this as a dissociation equilibrium. We can write Ka equals proton concentration times A minus divided by HA. And in this particular case, we can say pKa equals minus log Ka. We can even figure out what Ka is. We know that minus log Ka equals 3. That's our pKa. Okay? So what is Ka? Well, what we do is just simply we take both sides 10 to the power of, we bring the minus to that side, so we have log Ka equals minus 3. And then we take both sides 10 to the power. 10 to the power of log Ka equals 10 to the power of minus 3. 10 and log cancels out. So our Ka equals 1 times 10 to the minus 3. Make sense? And if we just simply put that up here, equals 1 times 10 to the minus 3, it basically tells us that heaven's sake. That here we have one molecule and one molecule, whereas here we have 1,000 molecules. So only one molecule in 1,000 will dissociate. So it's very, very feeble. Actually, this acid here, in reality, doesn't really have a huge inclination of giving off its proton. It goes like, it's mine! My proton. My proton. Hands off. Paws off. My proton. Try to get it back. Up. Get it off. Get it off. Oh! My proton! Lost my proton! My proton is gone! Ah! My proton is gone. I need to get it back. Right? What makes me, if I lost my proton, what am I then if I don't have a proton? If I want to have a proton, what am I? I'm a base. Am I a strong base? Think about it. Am I a strong base? I want this proton. Am I a strong base? Oh, mine! Oh, he's got my proton! Give me my proton back, please! Am I a strong base? A very strong base in this case. I'm a weak acid. I don't want to give it off. But when I have given it off, I want it back desperately. So, a weak acid, the anion becomes a strong base. Or a strong base, when it has grabbed its proton, it becomes a weak acid. Does that make sense? And actually, what we can do with this, we can say, okay, pKa, that indicates how strong the acid is. And we can also formulate something that's called the pKb. The pKb indicates how strong the conjugate base is. So if I'm a very strong acid, if I'm a very strong acid, like HCl, what is the conjugate base to HCl? So HCl, this is the acid, right? What is the conjugate base to HCl? Cl minus. Cl minus is the conjugate base. Remember, conjugate base means It's the acid minus a proton. Yeah, that's the conjugate base. So if I'm a very strong acid, my conjugate base is very weak. In this case, HCl wants to get rid of the proton. I'm so sorry about your headphones. So I'm a strong acid, right? Have it, have it, have it. I don't want it, I don't want it, I don't want that. Ugh. Yeah? Protons. Ugh. And now you try to give me them. No, don't want that. No, don't want it. Yeah. Oh, protons. I'm HCl. I want to get rid of them. I don't want them. So my base, my tendency of getting the protons is very weak. I don't want them. Not at all. Make sense? Shall I let you into a little secret? pKa plus pKb gives us a magic number. It's 14 again. It's from the ion product of the water. So 14 is the magic number for pHs and pOHs. So, let's say I have a pKa. My pKa is 2. What's the pKb? Is 12. So, is it a stronger acid or a stronger base? Loud? Why? The lower the pKa value, the stronger the acid. Exactly. So, what would be in the case of pKa 7? What's the pKb value? It would also be 7 in this case. So, it's a sort of in the middle. Not terribly strong acid, not terribly strong base in this case. It's equal, basically. What has a pKa of 7? Loud? Water, exactly. So that's the scenario for water. We have a pKa of 4.75. What's the pKb? Equals? Yeah? 9.25? Is this a stronger acid than water or a weaker acid than water? It's a stronger acid than water because the pKa is lower than my 7 here. This is actually acetic acid. Okay? Let's have a little bit of fun with acetic acid. It's basically the stuff that you put on your chips, which I find totally disgusting. In my view, only ketchup should touch chips. You agree?
No, burger sauce.
Sorry, no?
No, burger sauce.
Burger sauce on chips.
Yeah,
Mayonnaise, anyone? Yeah? No? Red and white? What's that? It's ketchup and mayonnaise. Disgusting.
That's good.
It's good. Okay, yeah. Okay, let's do a little calculation. So acetic acid obviously is an acid. It is stronger than water in terms of acidity because excuse me, the pKa is lower than 7, which is water. pKb, is it a strong base or a weak base? It's not terribly strong, the base. Weak acid, but it's stronger than water, the base. So it would grab a proton from water in this case. So what is the pH of a 0.1 molar acetic acid, pKa 4.75? Strong acid, weak acid. What did we say? It's a weak acid. Weak acid. So we need to use the equation for a weak acid. And in the lecture, I gave you this equation for that. pH equals half of pKa minus log of the acid. Okay? Yeah. There was a sort of a slight inflection at the end of your sentence. It was almost like, is that right?
Yeah, 'cause I don't have calculators. So.
Oh, yeah. So, we have half of 4.75 minus log of 0.1 equals half of 4.75 minus log of 0.1 is minus 1. So we get here half of 4.75 plus 1, half of 5.75 and half of 5.75, 2.875. Is that right? 2.88, something like that. Yeah? Compare that to hydrochloric acid, to the same concentration of hydrochloric acid. Hydrochloric acid 0.1 molar is pH of 1. So here we are significantly less acidic than the same concentration of hydrochloric acid. That make sense? Yeah? Okay. We have a pH of, what do we have? We have an acid pKa is 4. That is what we know. And we have a concentration of 0.01 molar of this acid. What's the pH? pH equals 3. Why? Absolutely right. So pH equals half of 4 minus log of 0.01. And that gives us half of 6 equals 3. Wonderful. We know we have a weak acid. We have 0.01 molar of this acid, which gives us a pH of 3. What is the pKa? How can we address that? We'll just rearrange our equation for the weak acid because we know it's a weak acid. Yeah? So, pH equals half of pKa minus log of the acid. So we have to solve this equation for pKa. So first of all, we bring the half to the other side. So we have 1/2 of 3 equals pKa minus log acid. Now we bring that to the other side, and we have 6 plus log of, what was our concentration? 0.01. 0.01. That's our pKa. Log 0.01 is minus 2 equals 4, and that is our pKa. And that is actually how in practice you determine the pKa of a weak acid. You just take a defined concentration of this acid and measure the pH. And from this, you then can very easily calculate what is the pKa. You don't have to do any complicated, equilibrium stuff and measurements and things like that. You just take a defined concentration, measure the pH, and Robert is your mother's brother. Bob's your uncle. Yeah. Does it make sense? Everybody clear? Have a lovely weekend.